Hi, in this project, as the name suggests, we will be predicting the number of affairs a person might have. Then, we will build or develop a web application based on this machine learning model and deploy it on Heroku. So, moving forward, what are we going to do in this project? So, we have a dataset that contains information about people who were caught having affairs. Now, this is a little complicated and not so outspoken topic, but moving forward, so it states out some of the characteristics of these people that includes their occupation, family information, and more. Then we have or we will be using this data set to predict the number of affairs a person can have or already had. So the details of the project. Now the project is divided into three parts. The first part is building a machine learning model to predict if the person will have affair or not, and if he or she has, then how many. Next, we will build a web app or web application on Django to mount this prediction model. Lastly, we will deploy the Django project on Heroku using GitHub connections. So the machine learning model. Now we start off with building a machine learning model where we use a random forest regressor model and train that model using the affair data points or our affair data set. Next, one thing to note here is that here the data set will require more feature building and extraction than exploratory analysis, which will be clear in the upcoming video. Now there's a reason why I took this data set, because it shows a particular situation which might occur later on where there's an imbalance of classes, which I will explain in the next upcoming video. Okay. And another thing why I used this dataset was we will be using PCA, and you will see that in action and understand why it is needed and how it helps in reducing or removing dimensionality curves. So next will be our Django web app. Okay, this is the second part of the course where we will be building the web application using the framework Django. Now we mount the model we built in the previous part on the Django project here. Lastly, we will be deploying our project or web application on Heroku, and we will be doing this using the connections to GitHub. So moving forward, we will now start with building our machine learning model from the upcoming video. Hi, so this is the machine learning part of the project where we will be building the machine learning model. Now we will be building a model for prediction of affairs or the amount of affair a person could have or has already had. Okay, and so let's move forward and see what all is included in this part of the project. Now first, we are importing the necessary libraries. One thing to note is that these are not all the libraries that I would be importing in our project. The libraries which are actually used for prediction and for maybe feature extraction are also included, but at a later part in this code. Now the first code block that you can see where I'm importing the google.collab and import drive. So this block here is to mount the drive folder onto this collab notebook, meaning now we can access the files stored in our drive folders from this collab notebook. And here you can see I'm mounting the drive folder that is inside the content folder or directory. And next you can see again that I just now said is importing necessary libraries. And you can see NumPy, Pandas, Cbond, Matplotlib. Now some of you may know what these are, but again I would be giving you a brief of all these libraries and what it can do. So the first library is NumPy. It is a library consisting of multi-dimensional array objects and a collection of routines for processing those arrays. Using NumPy, mathematical and logical operations on array can be performed easily and efficiently. Next, you can see is the pandas library, giving the alias that is PD. So it is a library for data manipulation and analysis. In particular, it offers data structures and operations for manipulating numerical tables and time series values. Next you can see are the Seaborn and Matplotlib libraries. So while Seaborn is a library for making statistical graphics in Python, similar to Matplotlib, but Seaborn helps in exploration of your data in a much more visualizing and realistic way. Matplotlib can give you a lot of graphs that can be built on according to the situation and the data, but Seaborn has a much better visualization aspect as compared to Matplotlib. So one thing again to note is that the affair column is a float type and not an int type, as you can see here. So we will be assuming or rounding off the values here. With this, you can understand in a way that this is not a really good data set. And that is true. This data set is not really good in the sense that the data that is provided by this data set is a little impractical and irrational in some of the ways, which again I'm going to show you in the upcoming part. The first thing that you can already see is that affairs, the first person having affair is a value of 0.11. Now again, you can either have one affair, two affairs, there's no half, no 1.5, 2.2, such kind of affairs, okay? Or I'm assuming there are not. So moving on to the next part, you can see that the shape of this data set is 6366 and 10, meaning there are 6366 data points, okay, or rows, and there are 10 columns, one which is a target variable, that is the affairs, okay. Again, what I am going to now do is look for how many null values are present in each of the columns, and as you can see there's only okay, yeah, there's no null value present in each of the columns. Now, in this sense, you can say that, yeah, the data is good. There's no null value present. You don't have to impute values or remove values as such. But the data set is really bad. But it has something that I wanted to show, and that is why I've picked up this data set. So I'm removing the unnamed column because this was just the index column that was present inside the CSV file, which we don't need, as pandas already provides you an index, okay. So after removing, just like I said, I have just rounded off the values, and as you can see the values are now rounded off to an integer value. Next is something that helps us in understanding more about the data, or more about the relations between columns inside the data. So as you can see, I'm using the course. Actually, this is a function which helps in finding correlation between values or between columns in your data set. And this, as you can see, is a Seaborn heat map that I have built. And I've already set the figure size as 8 by 8 using the matplotlib function figure. Now you can see there's some values present here, and it ranges from maybe minus 0.2 to 1. So what does 1 indicate? What does negative value indicate? What does positive value indicate? So first of all, one thing to realize is that the correlation values range from 1 to minus 1, both inclusive. Okay, and if there's a value of 1, that means that the two columns, as I can say that the marriage rate and the age, are having a correlation of minus 0.11. Okay, this means that there's very less correlation between both of these columns. Now when I say less correlation, what does that mean? So it means that if there's a change in the column age, there will be very less or negligible change in rate marriage column. So one is not influencing the other. But if there's a value of 1, that means that column A, let's say there are two columns, column A and B. So column A is 100% influencing column B. Whenever there's a change in column A, there's definitely a change in column B and a positive change. If there's a value of -1, what does that mean? So it means that, let's say column A changes, then there's an inverse change in column B. Now, what is this inverse change can be only seen through data. This is not like there's a plus change, then in column B there's a minus change. Not like that. But there's an inverse change in column B. So if there's a value of 0.67, that means that children is able to influence age, but not to a very high extent. Okay, now there is a value of 0.89 also, which means that there is a high influential rate, that is on years married and age, which is kind of also something that we would call common sense, that as people age on, they tend to get married, right? Now there are exceptions, but I'm not including those. So this is what a correlational graph that I've used heat map function and built, and you can see that there are some parameters. Now these parameters are actually helping in making it more visualizing and appealing, right? So if I have just built a correlation graph, you would have seen a matrix type of thing and all the numbers would have been present like a NumPy 2D matrix. But with heat map, it has built you a 8 by 8 figure with colors indicating the correlational value, not just the values present here. You can see that one is presented with a yellow, and as the value goes to the negative part, the boxes darken, and you can also uh, set up how large a box can be, what would be the width of this wide, this thin white line, with the line width and all. Cool. So moving forward, now I've given just a basic description of what you can find from here, and yeah. So next is the describe function. Again, this helps you in identifying or understanding more about the data, again column wise, right? So it only takes as its input all the columns that have float or numerical type of data. Okay, so int, float, block, that type of data. Now you can see that the count, it tells you the number of rows present. Okay, the mean for each of the columns, you can see here the age mean is 29, years married is 9, and so on. The standard deviation, again, those who have already studied something in economics would be maybe able to understand more from this describe function and maybe inference more from this, right? Those of you who have no knowledge about what standard deviation is, what will it help in understanding, you can just use the mean, max, okay, and the percentiles. Now if you have no understanding of percentiles, again I would like you to go and look for quartiles, percentiles, and how do you infer from them, right? Because there is one thing that you would be inferring from here, which tells you about the imbalanced classes. I would be explaining what imbalanced classes are, but from here, as you can see the affairs part, right? In the affairs part, you can see that for the minimum, the value is 0, meaning the person didn't have any affairs. Then there's a 25 percentile, 50 percentile, 75 percentile, and till 75 percentile, the value is still 0, right? What does this mean? This means that till the 75th percentile of the whole data, the values are still 0, meaning that more than 75%, I would say till the 75 percentile, the values are just 0. So let's say there are 100 people, then 75 people have not committed adultery, or I would say they haven't had any affairs. But the most astounding thing is that the maximum value of this affair column is 58. That means the person had committed 58 affairs. You okay? Like 58 is a very large value by anyone's standards, right? 58. Okay. So moving forward, now we will be doing some feature selection and exploratory analysis to understand a little more about the data, right? So I would be starting with this from the next section. Right. So this is the second part now where we will be understanding or actually inferring from the data. Then we will see what all that we can extract through this data that will help us in model building and predicting. So the first thing that we are building is actually a scatter graph. Okay. This scatter graph will help us in looking out the education and affair relation. Okay, meaning that you can see from this graph that there are some education levels, okay, that ranges from maybe 9 to 9 to 20. Okay, and then there's the affairs. So what does this graph actually tells you? You can see that for the education level 10 that there is no affair, okay, and for again for the 18 there is no affair, but you can see that for the education level 14 there's the highest amount of affairs that people have, and it ranges from a very less value, maybe actually it ranges from 0 and goes till 58 that I told you, right, the max value. So this max value was for the person who had an education level of 14. And again, you can see that it kind of has a bell curve shape, meaning 14 having the highest, it again goes downwards or actually goes decreasing on, and again gets a little at the 20th education level. And again, similarly for the education level 9, there are less number of affairs as compared to others. Yeah, as compared to others. Yeah, so this is what I have actually built a scatter graph, and this is a little brief about what I'm going to or what I've already inferred from this graph, right? And yeah, so again, loyal people are at level 10 and 18, you know. Then we are building an histogram, okay? And again, we are going to find a relationship between children, number of children, right? And the affairs. But what is, incredible is that the person, that had the maximum number of affairs actually had an child. You can see people who don't have any child, the maximum number of, or I would say the maximum number of affairs that a person having not one child reach still maybe 39. Okay, and a person, let's say that there are categories, category 1 having 0 child, category 2 having 1 child, and so on. So for all of the categories it tells you the maximum in the particular category. So category 1, which had people having no child, the maximum went to 39, and people having one child had the maximum went to 58. So this is, yeah, this is not really good. And as you go or as you move forward with the number of children till 5 and 6, it kind of vanishes, right? So this is what I wanted to show. Now, according to the norm, people would think that, yeah, maybe the couples having no children might be having more affairs as compared to others, but yeah, this graph really doesn't show you that. Lastly, now we are building a box plot, and that is with the help of our Seaborn library, right? In the box plot, you can see that there are a lot of dots and this one big line. Now, box plot don't look like this, right? Box plot basically is an visualization that shows you the quartiles that we just looked above here. Okay, it would give you the mean, the minimum, the maximum, and the quartiles. And lastly, it would also give you the outliers. Now, how it is actually depicting the outliers in the graph is that it would give you the points. But as you can see, there are only points in a line. There's no box, right? So this is the prime example, or I would say this is the like the major indication that your data is imbalanced to the point of no return. Because if your data was balanced, then it would have been a box like this, right? A box like this, the outliers would be outside the boxes and a mean would have been given you, actually had been given to you, right? But as you can see, the box is squished to become a line, and all the data points are actually outside the box, meaning all of these are outliers. So this data set is considering itself to have zeros as its mean values, or I would say that zeros as its, I would say, major values, and all of the other values it is considering to be outliers, which is not good. Assuming that we are going to predict the number of affairs that a person might have, right? And this is the reason why I took this data set as such. And again, you will be actually looking at the reason why we are not getting a box plot as it is, but just a line with a lot of outliers, right? Now, yeah, here you can see that I have now divided the dataset into two parts. One where the affair count is 0 and one where the affair count is greater than 0. Now if you can see the shape of the affair count having 0, it is 4788. Now remember we had 6300 plus data points, from which 4788 are just zero values for affairs, right? So major values are actually zeros in our data set. And that is the reason when we are actually trying to plot the box plot, you can see that it is thinking that yeah, zeros are the major values. So our mean or our values that are considered to be normal are inside this box, which is not a box, just a line telling you that 0 is the point, and any point that is above 0 or more than 0 is considered to be an outlier. So what I've done is I've taken the first 500 values from the affairs. Okay, and what I've done is, oh sorry, yeah, so actually I've taken the first 500 values from affair 0 and appended that data set, which having 500 values, to the affairs data set. So like the affairs data set were all the affairs were greater than 0. So now we have a mix of greater than zeros and also zeros, right? And as you can see, the data set now has only 2000 data points, a little more than 2000 data points, having very less zero values as compared to before. So in this way, you can say that you have now having an imbalanced class. This is not exactly class, but data points. But again, this is similar to that only. And now what you have done is mixed and generalized the data more as compared to before. Having 8700 data points, only zeros, and some values having value not that is not zero, will hamper your model in prediction, because the model will then think that the major values or the values that have the most frequencies are zero. So it will give more importance to the zeros values, or and the prediction then would be a little, what I would say, the prediction would be kind of hazy and not accurate at all, right? But with this, we have a lot less zero values, and the model will now understand that yeah, there are some data points having zero values, but it will not generalize on those zero values only, because there are a lot of values having, value that is not zero or more than zero. The next thing that we are doing is looking for categorical data points or data columns, right? And you can see that the children only has values ranging from 0 to 5. Now there are 0 to 5, okay? And Then there's affairs. Yeah, this is the education part that I was talking about earlier, right? So there's only one, two, three, four, five, six education levels. Now, again, one reason that I told you that this data set is not really good is because the wherever I got this data set from, it didn't specify what the value 14 indicates. Does it indicates the value that the person has passed school or has passed college, maybe doing masters? What is he or she doing, right? So you can just know that the lowest value is 9 and the highest value is 20, and assuming that the 20 is like he has done PhD or something, right? So moving forward, we have the rate marriage. Yeah, this is a really important column, I would say. And again, you can see that most people have actually rated their marriage as 4, and then 3, and then 5. So 5 on 5 is not as much as I would say there should be. So most people have rated 4, that yeah, the marriage is really good, but not like totally excellent or outstanding, right? And the next is religious, or again, here it is written religious. Four values are presented, but it hasn't been told that value number 2 is for Hindu or for maybe Christian or some other religion. So we can just assume that there are four religions that have been accounted in this data set, and the number of values each religion had. So this value count function is actually giving out an dictionary which provides you with the unique data that is present in your column and the number of times each unique data was present inside that column. So you can see that the number 2 was present 830 times inside your data set, or had the frequency of 830, right? Next, the same I did for occupation and occupation of husband. Yeah, this is a really this is a really cool column which actually tells you that this data set is actually about women in general and not about husbands. So kind of sexist, but what I can say. Right, then the next thing is we are using get dummies. So this function is actually present in pandas, which helps in extracting the data, right? Or extracting more data from categorical data types. And here you can see that I've input the column that I want the data extracted from. And then there's a prefix, which you will understand later on what this parameter does. Okay. So I have done the extraction on rate marriage, religious, occupation, and occupation of husband. And now appended all of these new data that was created into my affairs data frame or data set, right? And then dropped off the old columns because now I don't need those, right? And now you can see that the shape having 2000 data points and 20 columns. Yeah, we went from 9 to 20, right? Now as you can see, there's rate 1.0, rate 2.0, and then religion, and then husband, occu, and so on. So as you see, I gave the prefix rate, religion, occupation, and occupation husband. And here you can see, yeah, and here you can see the prefix were now appended for the column. So the prefix was actually implemented for column names, which would be created when we were extracting the data from categorical data columns, right? So next thing you can see is that I've used PCA. So from this point on, you can say that we have now done all the feature building, feature selection that we could. The last thing that we are going to do is that we are going to use PCA to reduce the dimension and then use the random forest regressor model to start the training for the model. And this would be covered up in the next part. So right, so we have now PCA, we imported the PCA library and used the fit transform function from the PCA. Now, what is actually happening here, right? There's a parameter also named n underscore components, and I've given it the value 15. So what does this mean is that now PCA is a, I would say, a box, right? And you provide your dataset as input, and what it does is it finds the most important parameters from your dataset, and it then squishes the data set so that, let's say that we had 20 columns, right? We had 20 columns, and it squishes it down to 15 columns. So it reduces the dimension of the data set and tries to retain all of the information that was present in your dataset initially. Now, if you're trying to reduce the dimensionality from maybe 20 to 3, obviously there's going to be a loss in, information. But what it helps in doing is that it gives you a trade-off between dimensionality and the information loss. If you're going for a lot of reduction, then of course there's going to be a loss in information also. But for 20 to 50, going from 20 to 15, maybe going from 20 to 10, it is still able to retain most of the information, right? So this is how PCA helps us in reducing the dimension. And now there's a misconception that what PCA does is that finds out the most important parameters or the columns, okay, and the least important ones are just removed. Now they are not removed per se, but some of them are merged into the important columns and some of them are just left alone, right? And this is how, in one way, PCA is able to reduce the dimension and provide you with a much concise, with most information still ready for the model to predict on. Next, we are using the train test split function. The first parameter is actually the PCF fit dataset. Okay. The next is the test size, where we are telling that 20% of the data is to be used as the testing dataset. And the random state is equal to 1, telling that you can shuffle the data before we feed the data into the model. Now next we are initializing the random forest regressor, having the estimators as 300, random state as 0, telling that once the data is fed to the model, you again don't have to reshuffle the data, right? And n jobs is equal to -1 is just telling the processor that all of the processes are to be used for training the model. Now we're using the fit function to train the model, and then using the predict function to predict after the training has been done. And from the accuracy, we can see that there's an 82.19% accuracy, which is okay. But if you would haven't had done the reduction in, yeah, if you haven't had implemented this, okay, and just use this data set as whole for training the model, you would have gotten a very less accuracy, which I tried first, right, to see how less it goes, and it went to maybe 20%. Yeah, 20% accuracy, which again tells you that once you have an imbalanced data set, then the model is not able to predict properly, because it starts to generalize well on the majority class or the majority value, and the minority is not given that much preference, or even that the information is not extracted with high precision, and then the prediction, the quality of prediction just goes lows and lows, and the more imbalanced the data set is, the lower the prediction quality would be. Okay. So with this, we have trained the model, built the model, and now we can use this model directly in our next part, where we will be building a Django web application. But lastly, what we have done is import pickle. So pickle package helps us in storing the models, right? So we have stored the random model using the function dump and given the parameter that is first the model and the place where we're going to store the model. Similarly, I also stored the PCA parameter because again, whenever we get the input, maybe from the web application, we have to first transform the model into a PCA type, and then we can feed the data into the model. Okay. So with this, we have completed the first part of the project, that was building the model. And in the next part, we will be building the web application where we are going to use this or mount this model, right? Part where we are going to build the web application, that is using the framework Django. Okay. And we're going to mount the model that we built in the first part, that was the machine learning model here. So before we move forward and start setting up the project, that is the Django project, let's understand what Django actually is. So Django is a Python-based free and open source web framework that follows the model, that is model template views architectural system. Okay, it is a web framework that has a set of components that helps you to develop websites faster and easier. Now, that you have understood the framework Django, it might be a little puzzling what model framework or what model view framework architecture, what is all of that, right? So there's no need to like go into a deeper detail and understand each and every component of that. But each and every time that you want to build a website using Django, so Django provides you a pre-built set of pages and part where you can add on or maybe append something, use or change existing part of the code to make changes in the web app itself according to your wishes. So rather than creating each and every page, Django already provides you with some code that is used and that has already set up some like maybe security measures, like maybe handling the sessions for the web pages and so on. So rather than building everything from scratch, Django provides you with a predetermined and preset website on which you can add on things, and it will like the changes would be then shown on the website itself. So before moving forward and using the code, let's first set up the environment. Now first create a project directory like I did, which was affairs on my desktop. Then go and build an environment. Now if you're using PyCharm like me, it is very easy to build an environment. So what you can do is just go on to the file, right? First open the project using the PyCharm, then go to the settings, and once settings open, go to the project affairs and then project interpreter, and here there's a add button and show all button. If I click on show all, you can see a lot of environments have been built, right? And here you can see that you can also choose from existing environments if you want to, or just click on add, and once you click on add, you can just build the new environment and the location where you want to save the environment. Now you can see that some of the packages are already installed on this environment, and next thing that we are going to do is say install the packages that are required by this project. So once you have built an environment, go to the my site directory. Okay, so you can see that now I'm inside the affairs and then I'm inside the my site directory where where my site directory, polls directory, and some of the files are present. So inside here, what you have to do is run the command pip install r requirement.txt. So once you just click on, write this down and enter. So what happens is all of the packages that are present here, all of the packages that are present here will be then installed inside the environment with the all of the package and the versions of them, right? So all of the packages and dependencies would be installed inside your environment that you set up just now, and then you can move forward and start using the Django application, that is the code. So once you have done this and all the packages are set up or installed, what you have to do is run this command python manage.py migrate. So this migrate is actually a function which is defined in your manage.py, right? So it is already calling some set default things, and from there what happens is that with this migrate functionality, Django understands that now we have to build the tables that come up with the preset Django application, and we have to now instantiate the tables that we are going to maybe use later on, or maybe are going to be used by the user later on, right? So all of these packages, sorry, all of these tables will be then instantiated, and also will start storing values according to the settings of the Django application, right? You can even see that there's a db.sqlite 3 instance build, and inside that the tables data would be stored, and maybe the values, if they are being stored in the tables, will also be shown there. Okay, so now once the tables have been set up, environment has been set up, you are you have been able to understand the code also as to how it is working. What you can do is the last is the running the code, that is python manage.py run server. Now run server basically indicates to Django that yeah, the code has been set up. Now we can deploy, or we can develop a local host or a local server on the platform or on the laptop, and then that server is to be run and the code is now to be used. Okay, so Django, you don't have to again download anything or install any new package or something. Django already provides with you a development server, and you can just directly run that server to see how your website is looking, or if all the functionalities of the website is now working. The first thing that you have to understand is that this my site here is the project folder, and this polls here is the app folder. Now project folder is like administrator for the Django application, and the polls are like the sub branches which helps us in building functionalities, like different functionalities on the website, right? So if you click on this, or if you go inside the my site directory here, you can see there's some ASGI file, settings file, VSGI file. So mostly this and settings file are going to be used. If you're building an web app which is something like WhatsApp web, or something like where synchronous messaging has to be done, then ASGI file is going to be used with some of the other files also, like consumer files and all. So first of all, let's go to the settings.py file. Yeah, let's scroll back up. So you can see that a base directory is being set up, and this directory is the path where your Django application is present. You can see a secret key, debug, allowed host, right? So things to understand are actually present from here. You don't have to understand what secret key is doing. So first of all, there is already a warning telling you that a security warning, that is, don't run with debug turned on in production. Okay, so what does debug do? So if you're writing an application and you're writing your code, and now you're trying to run that code on the server, so what happens is if there's an error and debug is equal to true, then a long list of traceback errors is shown on the page. But if your debug is equal to false, then only a 404 error page will be shown. So when you are developing the app or the Django application, you can keep the debug is equal to true. But once the application has been developed and tested, and you have now appended or uploaded the files on the server, then you have to keep the debug as equal as false, or else the some part of the code or the error will be shown on the web page, and anybody can then understand what the code is about and maybe try to hack it. Next is allowed host. So allowed host is basically telling that which server or which DNS servers can use this code to run, and on where. On, like, there's www.google.com, right? So that URL is present where you, if you input that onto the your browser, you can go to the platform, the Google, right? So similarly, you can input the URLs here, and it would understand that this DNS servers are to be used, and the code will be present, or the code can be requested from these servers or through these URLs only. Next is installed app. As you can see, there's a auth app, content type app, session apps. So what I was talking about, that Django already gives you a preset build project, and you don't have to work from scratch, right? So all of these are already built by Django whenever you're starting your app or project, and you don't have to write the code or code for the sessions, for the authentications. It is already provided to you by Django and is also handled by Django itself. So like you can see that I've talked about polls as an app. Now this app was created by me. This was not created by Django. So now I've just included that. And again, in my polls app, I can build function which will provide me with functionalities that I want on the website, as you will be seeing in the upcoming part. So even the middlewares are already present. You don't have to code, or you don't even have to update the middleware. Okay, unless you're a really advanced Django practitioner, you don't even have to update the middlewares, as they provide you with a very fixed and set parameters and code which will help in handling the Django application even without your notice. So this talks about the templates which I was talking about, right? The application model template views. So the templates are actually all your static files, which can be HTML files or maybe CSS, Java, right? So all of that handling is done through this part. You can change or add on the context processor. Okay. Next is your about the database. So I'm just using the default version, which gives you an SQLite 3, right? And then there is authentication, password validations. With the help of all of these validators, we can, without writing any code, directly validate or authenticate a user. The last part is about static files and storing static files. Now the server wants you to specify where to store the static files, and that specification is through this. That is, static URL is this, and the static root or the folder where the static files would be stored is this, right? So these are some of the settings that you have to change or maybe update so that you are able to use your Django application. So once this has been done, let's move forward and understand what this polls is about, right? So in polls, you can see migration templates and some of the files. Now you can see the affairs pickle files, right? Affairs pickle files and affairs PCA pickle file. So these are the models that I stored in the last part, which are now I'm going to use after loading them. You can see that the template is storing the HTML file right now. So if I go to the HTML file, you can see that, okay, this is the CSS part, install CSS, right? And after that, you can see that a form has been created. So the form is taking some of the values here, like a lot of values here, and then I'm just using that button to submit those values. So what happens is, first I'm building the form from where the user will input their data, and then the user will submit that data, and that data would come from the front end to the back end here. So there is this index function, okay, and using the request dot method function, I'm able to understand that the form was created, okay, and the form is taking some of the values, and using the request dot post function, I'm taking all of that values and storing them in all of these variables. Now the next thing I'm doing is building a data frame where I'm going to store the value of these variables, right? And I've built some of the helper functions that are used to extract some of the data. And once I've done that, I've built the data frame. So now this data frame df knows the columns and the values for it. And using this data frame, I'm going to input them into first my PCA component. Now once this transforms the data, meaning here you can see that 20 columns were present, and after transforming we remember that 15 columns were present, right? So after transforming the data, I have just loaded the next model, that is my actually random forest regressor model, and using the loaded model I'm going to predict here. So I get the result. I'm storing the result as integer, and then I'm maybe printing the result. Okay. So now you must be thinking that yeah, the data is now coming from the front end to the back end. The data manipulation has also happened. Now you're already with having your results also. So how do you send back the results? So the results are sent back using the context. Now this is a very important function, the render function. What it helps us is that this render function understands that this function, actually this function, right? This function, not the render. This function is attached to a template, okay, that views model template views architecture. That template views part is how, or is with the help of rendering only. So this render function understands that there's a function which is going to manipulate the data, handle the data for this template here. So if I'm writing return render and then I'm specifying an HTML file, so to understand that whatever happens in this function, I'm going to load this file on the server, and if there's a context, this is called a context, then I'm going to use, or I'm going to send the context also with this file to this server, and then the server will load this file and understand there's context or information that is to be shown on this HTML page. So this is how this function works. So first you took the data from here, submitted to the backend. The backend is this function created here, storing the values, using the values to predict. And once the number is predicted, it is now returning that value using here the context. So this is not the only part that helps in understanding which function is going to be working on what part of the application, right? Because you now understood that this function is going to render the index.html page, but how do you understand that on which URL this function has to work on, right? Who is calling this function? As you can see, there's no function call here, right? So how this happens is that there's the urls.py file where you're going to specify the path, and on that path, once you go on that path on the browser, it understands that this function has to be called. So this function is called, and then this function once called, it understands that it has to return, or it has to render the HTML index.html page. So once it renders, the page is loaded, and on from that you can input the data, and then output is shown. Now this would be a little haphazard and conflicting, so I would just directly show you how it is working. So I write python manage.py run server, and once I write this, It takes a little time to load. And yeah, you can see that first Django is going to perform a system check. Then it sees that there's no issue. Then it says that starting development server at localhost URL. So this is the URL present. So once you click on this, a page will be loaded. You can see that the page is now loaded here. And also, as I told you, that since the path was empty, so this empty path was appended here. And since again, empty path is not going to do anything. So on this URL, index function is to be loaded, or I would say index function is to be called. And once index function is called, it is going to render the index.html page, which is shown here. Now, if you just click, just type in maybe, yeah, and I'm not 34, okay. Okay, right. Level of education 17, occupation 4, rate marriage 3, religion 3, level of occupation 3, let's say, and submit. So once you click on submit, okay, once you click on submit, you can see that the number of affairs this person have are okay, 4. I have 4 affairs. But you can see that now once I clicked on submit, the data was sent to the backend, predictions weren't done, and then the prediction was sent again to the front end to be shown here. Okay, so this is how the page is working, and again this is how Django is working. The next thing to understand is that once you have built the application on development server and now you just want to get your code onto the server, you have to specify allowed hosts, because Django by default understands that local host is to be used when on development. But when you have deployed, you need the allowed host to be the URLs on which this code is to be run. Okay, so at this part, we can say that the Django project has been completed. And next we will be working on, or I would be explaining how to deploy your code on Heroku, right? And for that, we have to build 2 files and write some input in them so that Heroku servers understand how to set up this code, right? So with this, we have completed the second part, which was building the Django application. And next, we will be working on deploying on Heroku. This is the third part of the course or the project where we will be deploying our web application on Heroku. But before we start with Heroku, we have to use some files which are like commands for Heroku to understand. So let's start with runtime.txt and proc files. So runtime.txt, as you can see, there is just one thing written, that is Python and the version for it. So runtime.txt is basically just telling Heroku which language or base is to be used by the server. And the next is proc file, right? So proc file is the mechanism for declaring what commands are run by your application in Heroku platform. The commands that are specified in the last part, like run server and migrate, these commands are executed in Heroku's server using the proc file. And even the log file is also created using the proc file only, where each and every event that is happening on the server is logged and that file is presented. If you want to see, there's an button on the server itself or the application of the server, that is Heroku, where you can click on and see the logged events for the server. So both of these files are important for Heroku to understand how to set up the code on its servers. So once you have done that, or maybe once you have understood all of this, yeah, not done that. Once you have already understood all of this, what you have to do next is that you have to create a repository on GitHub, okay, just like I did. And here you can see that on this repository, all my code is present. So you can see that my site, polls, flow.txt, proc file, all of those files are now present here. The next thing that you have to do is that create a Heroku account, or if you already have a Heroku account, just log in and on your dashboard, click on new. So once you click on new, there's a create new app. Click on this. Just type in the app name, choose the region. There's only two regions present, Europe and United States. Then create app, right? Since I've already created the app, it is now showing here, affairs findings. So if I click on this, there's going to be some, yeah, there's going to be resources, deploy, metrics, activity, settings. Okay. In the settings option, you have to scroll down and yeah, in the build packs, you have to add build pack, and that build pack will be the Python. So once you click on Python and click on save changes, it is going to add the Python build pack for your server. So once you have done that, again go back to deploy, right? In deploy, there are three options given by Heroku. You can deploy using Heroku Git, you can deploy using GitHub connections, you can deploy using connect container registry. This is for those people who have an understanding in DevOps. Okay. So the easiest way was GitHub Connect, and that is what you're going to be choosing. So click on this and it will ask you to log in with your credentials. And once you do that, it would give you a like tick mark telling you that now the GitHub is connected with your Heroku account. Next thing is what you have to do is you have to now connect the specific repository with this app. So first you will be asked to write the name or search the app name, sorry, search the repository name. Once you do that, then there's going to be a connect button here and you have to click on connect. Once you're done that, there's going to be a confirmation here that is given by that connected to this repository by this, that is your account. So next thing that you have to do is go and scroll way down to the manual deploy. Now in manual deploy, you have to choose the branch in which your code is present. As you can see that my code is present in the master branch. Okay. So I go to the master branch and I click on deploy branch. Now this is going to take some time because now the server is setting your code into itself with the help of Heroku. And now you can see that Python app detected because we had chosen the build pack from settings, right? Heroku/Python. And the next thing is that it is taking the specified version, yeah, right, specified version Python from the runtime txt. Next, it is installing using pip, that is through the requirement.txt file we had, right? After that, it is using the collect static function, okay, or the command. Yeah, it is better to say command, which is actually storing all the static files that your web app has and then storing it into the static files folder that is now being built in the server only. So once it has done that, it compresses some of the files and releases the app as it has said. So if you go, yeah, just wait a little bit for it. There's going to be a view button here, and once you click on that, you can go to the web app that is now hosted. Yeah, as you can see, you click on view, and this might like take a little time, and you can see that the app is now hosted. So you just type in, yeah, type in anything, and yeah, I've clicked on submit. So as you can see now, the number of hairs this person has is 7. Yeah, nice. But as you can see now, the output is shown here. So with this, we have now deployed the web application that we have built in the last part, and now the project as such is complete.